Hello everyone, welcome to another video. In this video of this new series about AI, I just want to share with you my journey into the AI world. I'm a complete newbie when it comes to AI understanding, except as a base ChatGPT user. And so, one of the goals I have for this year is to get deeper into this AI world, see what kind of cool stuff we can do as a developer. So, trying to understand in more details what actually things do and how they are assembled. Okay. So I looked up some cool Udemy courses. I'm a person that really likes structured content. And I came across this course. By the way, no affiliate link, so I don't have any of that. I just found this course and I think it's really cool. Um, the teacher is awesome. He's wholesome as well. He's really, really great teacher, and his didactics, his way to teach is amazing. Okay, so I'm just going through this course right now. Uh, this course is structured by weeks. So this video will cover week one. What did we came across? What did we learn on this week and whatnot? And so, yeah, so keep in mind that maybe some of the info I'm going to share is either not completely correct, partially correct, incorrect, however you want to call it, because I'm still on my learning journey. So take everything I say with a grain of salt, do your own investigation, and so on. Okay. So, speaking of week one, each week is divided into 5 days. Okay. On day one, what we did was we started by checking Olama. Okay, so for those of you that don't know, Olama is just a way to run your LLM models locally. Okay, and they have a website that you can go to, and when you install Olama, it kind of looks like this. Okay, when you install it on your computer. Okay, it kind of looks like this. It has this user interface that kind of looks like ChatGPT, but the cool thing is that you have a bunch of models that you can install locally or run locally and interact with them. Okay. Uh, so one thing that we learned was how to check via the terminal that Olama was running or not. So you can use this Olama serve command to check that Olama is running. So if you have this error message, it actually means that Olama is running. And you can download, so to say, models by using Olama pool and then the model name. Okay. So if you go to Olama's website, they have a list of models that you can check, and then you can take the name and use it here. You also have them here if you want to, the most famous ones. You can also search here for something GPT, and then it will give you some of them, okay, that you can, as I said, run locally. So that's the purpose of Olama. Olama will allow you to have a bunch of models, open source models to run locally, and then you can interact with them. And as I said before, you can select one of the models. Let's go to Llama 3.2, and you can just say hi there. Okay, and then you will get this ChatGPT-like interface where you will get some answer eventually, depending on how powerful your computer is, depending on what you have running there, you will get an answer. Okay, so how can I assist you today? I can give it something like, tell me a fun fact. Okay, and then it will give me a fun fact, and hopefully yeah, so you see, honey never spoils, that's a cool fun fact. And so yeah, so you can interact with this, and the thing is, this model is running locally on your computer, so everything is running locally, so there's no cost besides your machine getting burned. So yeah, that's it. So this was one of the things that we did on the first day, and then we checked some concepts regarding prompting. Okay, and I can go back to Excalidraw. So we spoke a bit about prompting. Okay, and in the world of prompting, what we were introduced was there is two main types of prompts, okay, that we can work with. There's a system prompt and there's a user prompt. Okay. So what I did now on Olama would be considered a user prompt. Okay, normally what we do on ChatGPT when we interact with ChatGPT is called a user prompt. So it's by the end user of the platform. Okay, and this user prompt is normally it represents the task that you want the AI to solve. In my case, specifically before, the task was, hey, please give me a fun fact. Okay. We will come to this user prompt in a minute. Okay. But there's another type of prompt that is called a system prompt. And this system prompt, it's normally transparent to you because this is defined by the developers that build the models and interactions with the models. Okay, so you normally, when you run things locally on your terminal, as I showed you on Olama, you always work with user prompts. But if you use Olama via Python, which we will do in a second, you can, on your interaction with the LLM, you can define this system prompt. Okay? And this system prompt is not it's the what it is a definition of the rules of the game. Okay? What do I mean by that? So you tell the LLM what kind of persona they will have, what kind of charisma. You can tell, hey, respond in a professional way, or respond sassy, or this kind of thing. So you define the persona of the LLM, the tone, the rules that will be followed by the user prompt. Okay. So technically, this system prompt should be long-lived throughout the entire interaction that you have with the LLM. So as an example of a user prompt, you can say, hey, example, you are an assistant that answers professionally and never speaks about politics. Okay, as an example. Okay, so anytime that you interact with the LLM, this is the rule of the game. Okay, so this is always there. Your user prompt varies. Okay, you can ask during your conversation for multiple things, but this is permanent and long-lived on all the interactions that you have with the LLM. These are the rules of the games, okay, of the game that you have with the LLM. Some often this is called constitution or context, okay, but yeah, just to be aware of that, okay. Now, what happens if now on the user prompt I say, hey, speak about politics, okay? What will happen? So the system prompt, as I said before, defines the rules of the game. It is what has the highest importance or precedence when it comes to collision. So in this case, we are in a clear case of collision. My user prompt is telling or asking for something that the system prompt says we should not do this. Okay? In this case of conflict, the system prompt always wins. Okay? It has the highest priority when it comes to conflicts. Okay? So I had no idea about this system prompt when I first started learning about this. I was aware of user prompts. That's ultimately what we normally do. But the fact that there's something, higher level that defines, the explicitly defines the rules of the game, and you can configure this when you interact with the LLM. If you run it, for example, from Python script, you can um, you can configure this, and that's really cool. We didn't do much of a practical example on this day, besides getting to know some basic theoretical basics and playing around with Olama. But then on on day two of week one, we started to go on more fundamentals. We started to understand about uh, dimensions of LLM engineering. Okay, so I can write it here. Dimensions of LLM engineering. Okay. And we spoke about three main ones. Okay, we spoke about models, tools, and techniques. Okay, we spoke about these three. Okay, and so far on my learning journey, I am mostly here on the models part. Okay, this is where we have open source models like the ones we saw on Olama. You have also closed source modules, models that are not available to the wide public. You have multimodals, multimodal, multimodal models, where you can generate images, audio, and so on. Okay, so this is, let's say, the low level. Okay, so this is where my journey is right now, trying to understand um, as best as I can this aspect. Okay, of course, we don't go into the nitty gritty details, but as an end user, what you should know. Okay, so then you have the tools. This is where we will learn things as Hugging Face and LangChain. I haven't reached this part yet. And we have techniques that contains calling the ChatGPT or Gemini API. Okay, I'll show you some examples of that. How to use RAG, fine-tuning of models and agents. Okay, we've only spoken briefly about APIs, how to call APIs of ChatGPT or Gemini. We did some examples of that, but we haven't gotten into the really nitty-gritty details of. We also mentioned briefly about agents. We did some simple example, but it's not like a really complex example. Okay, but my journey is still at the very beginning. Okay, so this is where I'm currently at. Okay, so pretty much this video will focus on this part. Okay, and also week two, which I've just wrapped up, also focused on this side as well. Okay. Only I believe on week three we start with Hugging Face. Okay. So as I said here on this models part, there are two types of models. Um, Availability wise, we have open source models and closed source modules. Okay, open source models are the ones that we saw, Llama 3.2, there's 5 from Microsoft and so on. But you have closed source ones. Okay. So the closed source models, as I said before, are models that are not available to the public. So they are protected by their entity. These closed source modules are normally called as well frontier models, as they are models that are leading the AI race. Okay, they are on the top of the line. They are the top of the top. Okay. Examples of this closed source frontier models, you have GPT from OpenAI, which they have an open source variant. You have Claude from Anthropic. You have Gemini from Google, and you have Grok with a K, sorry, from XAI. Okay. So this is just some examples of closed source frontier models. Uh, the companies that are behind those models, they are often also called frontier labs. Just as a side note, but yeah. You also have open source models that you can access and play around with, as we just did with Ollama. You have Llama model from Meta. You have Mixtral from Mistral, Qwen from Alibaba Cloud, Gemma from Google, which is a cousin model of Gemini, which is a closed source one, as we just spoke. You have Phi from Microsoft. You have a GPT open source model from OpenAI, and there's a bunch of other ones. Okay, this is just to name a few. Okay. And when you're interacting with AI models, okay, so you know that there are open source and closed source ones, but how do we interact with those models? Okay, one way that we were introduced a few years ago is through ChatGPT. Okay, you have a user interface, you do some prompting, and then you get some response back, and then you go back and forth. Okay. You also have calling APIs. Okay. Example, I call the ChatGPT API from my Python script, or I call a managed AI service like Amazon Bedrock, and that also does the deed. Okay. So you can call those LLMs with their API. Okay. And the third way that you can interact with AI is by running it locally. You run some LLM locally, and you use Ollama, or you use some Python scripts to interact with the model locally. Okay. This is normally called direct inference. Okay. Inference is just a fancy naming for running a model yourself. Okay, you run a model locally, you send an input, and you get an output. Okay, so this was so as a wrap up with this models part. These are the three ways that you can interact with your AI models. Some chat interface like ChatGPT. Also, Ollama has an interface. You call an API, and you do direct inference, meaning you run the model locally and you interact with it. Okay. Throughout the course, we used as a standard for interacting with LLMs. We used something called Chat Completion API, which was made famous by OpenAI's Python module. Okay, so the OpenAI, when they created their Python package, they had a structure for their API call, as well as a request and a response, and that got so famous that pretty much everyone adopted this standard. Of course, each provider has their own ways of calling the APIs and so on, but the chat completion part, which is the conversation part, that's pretty standard across the providers. Okay, most of them, if not all of them, adopt OpenAI's request response structure. Okay, and also OpenAI on their package, their Python package specifically, they extended it on a way where you could call not only OpenAI models, but you can call Gemini models and whatever you have. Okay, so they also did this job. Okay, I'll show you the practical stuff next. I'll just get through with this theoretical bits that we saw. Okay, so far we saw so until end of day 2, week 1, we saw system prompt, user prompts, dimensions of LLM engineering. Okay, um, and we took a small dive into the models part. Okay, we checked open and closed models and multimodal models. Okay, then on day 3 we took a bit of a dive into at least theoretically speaking, because this course is has a great practical part attached to it, where the teacher goes on and explains and does all sort of things that are for me really cool. So yeah, so on day 3 we spoke also a bit about theory. We spoke about, so inside of a model, so if you choose a model, so let's say Y model, okay, doesn't matter, but a generic model. Technically, models, they should come into 3 flavors. Okay, they come into a what we call base flavor, what we call chat, and what we call reasoning. Okay, or sometimes called thinking. Okay, so the base model is, as the name might suggest, like the scratch. Okay, if you ever work with Docker, you have the scratch image. So this is like the base, the equivalent of that for models, at least on my perspective. This is like a base model, does some basic stuff. So this base model, it accepts, so it takes a sequence of information as an input, and it tries to predict what's the most likely sequence to come next. Okay, that's what LLMs do in essence. LLMs are nothing but statistical models to predict the most likely sequence that you get next. Okay, that's all that LLMs do. Okay, that was also one cool realization for me, to understand that it's nothing but nothing but probabilities and statistics, and all of these complexities just at that. That's what models do. And so this GPT-3 was in this category, okay, on the base model. Okay, so GPT-3 was here on this base category. It just takes, as I said before, you have a sequence of information as an input, and then the LLM model tries to predict what's the most likely next sequence of characters that should come next. Okay. Then people started to use this model, this base model, as a Q&A type of thing. And so when they did the prompting, they would query the base model with, hey, I have a question, and they would actually use this question, blah, 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 and then they would somehow say, hey, answer, and then something, okay? So they would use this pattern to often interact with the base model. Okay. And so by having this structured way of interacting with the base model, um, you could force it to behave like if it was answering questions, like a Q&A kind of thing. Okay. And so OpenAI was attentive uh, on this usage pattern, and then they decided to create a more specialized model called the chat model. Okay. And so the chat model is nothing but a model that is optimized for this Q&A kind of interactions, okay? Or at least originally so. Okay? It's what we call a chat variant, or a variant of the base model, okay? So this is this kind of Q&A. This is what we normally do with the chat variant. And this model, this type of chat models, they expect you to interact in this Q&A style, okay? It's prompting style. And it is in this chat model, in this flavor of this model, that we started to introduce things like, or at least heavily use things like system prompts and user prompts, okay? Um, this chat model normally is really good when you use it for, as I said before, Q&A kind of interactions, but also for um, things like, hey, summarize this email or something. So this kind of more interactive sessions where you have this back and forth with the model. These models are good for that. Okay. Also, because they are not very resource intensive, they don't do a lot of thinking or reasoning. They are cheaper than the reasoning models, which we will see next. Okay. So when people were using the chat variant, they started to use some tricks to force the LLM to do some extra thinking, to do some extra reasoning. Okay. As an example, people would say when they use the chat model, they would write at the end, hey, think, how would you solve this step by step? Give me the output step by step. Okay? And again, this is one trick that people used to use. And then again, OpenAI, attentive to this, they said, okay, maybe we need to have models that are tailored for this kind of interaction. This is when the reasoning and thinking models came into place. And this, I forgot to mention before, when you used to interact with an LLM and you used to ask it, hey, in this case, the chat variant, you interact with the chat variant and you say, hey, give me a step-by-step instruction list on how do you think you'll solve this issue. This is normally referred to as a chain of thought. Okay. And this was, as I said before, this chain of thought interaction was the basis for creation of reasoning and thinking models. Okay. Uh, Today, in the current day and age, what we have mostly is so you still have chat variants and reasoning and thinking variants, but often today you have a mix and match between these two. Okay, so you have what we call hybrid models. Okay, and what we saw was that based on the interaction that the LLM or the based on the type of interactions you have with the LLM, it somehow detects, okay, this kind of interaction is more tailored for the chatting, then I'll probably use more of my chat flavor. Oh, this guy is asking for a more complex thing, so I need to think more. So let me use more of my reasoning. Okay, so it's more of an, as far as I'm aware, the strategy is the vanilla part today is more of a the vanilla part of models today is more of a um, of a hybrid model. Okay. Um, there was also some concepts that we introduced uh, when it came to um, this reasoning and thinking. Okay. So one thing we discussed about this reasoning is that LLMs, they cannot do infinite thinking. So they have what we call a reasoning or effort budget. Okay. So LLMs, they don't think infinitely. So they have a reasoning budget. Okay. So the reasoning budget or effort budget, it gives you an indication of the amount of thinking that an LLM can do. Okay, so it gives you the maximum amount of thinking that an LLM can do. There are ways that people or tricks that people do to overcome this reasoning budget. And one of the ways that the teacher told us was that when people, if they, in the middle of thinking, if they said to the LLM, if they write to the LLM, wait, so just write wait, that would um, that would make the LLM have to rethink what they were previously considering as the most likely output. Okay. Uh, I haven't personally tested this for some reason. When every time we write, at least on this chat APIs, chat inputs like Olama input or ChatGPT, whenever you write something, it always prevents you from writing something next. So probably I would have to do something like this with Python code, which I haven't done, to try this wait technique. But this technique of trying to uh, step ahead of the reasoning budget is called budget forcing. Okay, so you try to go extra when it comes to the budget. Okay. We also discussed still on now on day three. Still on day three, we discussed. So all of this that I just mentioned is day three. Okay, this is day three. I don't know if I mentioned before, but this is day three. So still on day three, we discussed about some limitations of LLMs. LLMs are great, but they have some limitations, and one of the ones we saw was they, even though they are not PhD levels. Okay, so they don't have this very when you compare it with a PhD has a really high domain knowledge on some specific area, and sometimes LLMs, they lack on this specialization when it comes to a specific domain. Okay, and sometimes so when you train an LLM, so this is one of it. So this is this lack of domain knowledge. Another one is when you train the LLM, it has what we call a cut-off date, or so this is the data. This is the date on which the LLM has knowledge about. Okay, so if you ask an LLM about what is today's date, it will tell you the date on which the cutoff was made. Okay, but if which means that it technically LLMs should not be great should not be great in answering questions about things that are just happening. But now, if you go to ChatGPT, if you ask what day is today, it will probably like, give you the right answer or ask for any recent events. That's because ChatGPT is a product built on top of the GPT model, so it gives the model extra functionalities. And one of these functionalities is to be able to um, answer questions about recent events. So actually, I haven't tested with Olama, but if I go to Olama and ask what day is today, uh, probably it also has. So, yeah, it's give you this kind of generic information. Uh, yeah, but anyway, yeah, it's might be some information. So I forgot to show you before. So that was the end of day 3. We also spoke a bit on day 3 about hallucinations. Okay, which were which was sometimes the LLM is completely wrong, but is so convincing in doing so. So it gives you a wrong answer, but it's really convincing on telling you that that wrong answer is the right one. So that's an hallucination. But I forgot to show you before the Olama website. So here on the Olama website, you can download it, but you can also see the kind of trickery that it works with. So you can search here for some model. Okay. So here you have, if you go to this models section, you have here a list of models, and then you can filter by, okay, I just want to have thinking models. Okay, we just spoke about thinking models. So models that are really focused on thinking, on complex tasks. Okay, cool. So then we went to day 4. Day 4 was also interesting as far as theory goes. So we first tried to understand on day 4. We tried to understand what GPT stands for. Okay, so G stands for generative. P stands for pre-trained, and T is transformer. Okay, so generative is the behavior that we spoke previously. So LLMs, what they do is, based on an input, they try to give you the most likely token or sequence of text that should come next. So that's the generative part. Okay, so it tries to guess what's the next sequence of information. Okay, the pre-trained is the fact that a specific model is trained with a lot of data. Okay, so in the case of GPT, in the case of ChatGPT specifically, you train, or the GPT model, it was trained on all the accessible information on the web and more. Okay, so which also has the disadvantage that I mentioned previously, which is you have to decide an end date for your model, so the cutoff date. So you will read all the information available on the web until today, and today is, let's say, is 2024. Okay, so it's not 2026, but let's say today, let's say 1st of January 2026, we this is our cutoff date. Okay, so the LLM is trained on everything that is available for it that was generated until the 31st of December of 2025. Okay, so that's the pre-trained part. So it trains with a lot of data from multiple sources. And then the transformer part is just the type of architecture that it has. Okay, the transformer architecture is something that we spoke about on our class, and this transformer architecture is the key architecture that is behind the LLM models today. Okay, it's a key architecture that is behind modern LLMs and the GPT models specifically as well. So what this transformer architecture, which generated by a paper from Google, I believe, called "Attention is All You Need." So this is the paper where they introduced, I think it was 2017-ish, I don't remember exactly the date, but they had a paper that was called, as I said, "Attention is All You Need," and that introduced, in some extent, this transformer architecture. So this transformer architecture is, we could live without it, but it makes the models much more efficient. Okay, so it makes the models much better at predicting results and doing it cheaply. Okay. And so the idea behind this transformer is it has something called attention, I believe, if I remember correctly, and that attention, it um, it allows you to know which words are more relevant in such context. Okay. Uh, yeah, you can search it up. I'm not too familiar with it. That's all I know. Okay. The teacher also mentioned that before we use this transformer architecture, we used to use something called LSTM, which was long short-term memory, which is a type of recurrent neural networks, but we didn't go into much detail on that part. We just mentioned that. Okay. Uh, we also spoke about the importance of parameters um, on models. Okay, and that was a big one. So let me go maybe to Olama. Okay, and you see this 20B, 120B, 2B, 4B, and so on. Okay, so this indicates the number of parameters that this model has. Okay, so if I go back to Excalibur, so speaking about parameters, so parameters are uh, variables, let's say, of the model that can be used to configure it. Let me give you an example. So let's say you're doing a dish, okay, and you only have two ingredients, or better, let's say you are on a music studio or recording a video, and you have a soundboard. That was the example that the teacher gave. You have a soundboard, and the soundboard only has two two buttons that you can adjust something from the sound that you get. If you only have two buttons, it means that you are very limited on the music that you can get as an output. Let's say the only buttons you had was, you have a volume button, you can control the volume of the song, and a button for, let's say, the highs and the lows. Okay, which means that you cannot control a lot the music that you get as an output. Okay, but if you have more buttons, you can control more the output that you get. And if you can control the output that you get, you can tune them, you can tune those buttons in a way that the music that you get is perfect for the use case that you want. If you want a more, let's say, slow down, sad music, you can adjust the buttons so that all the music produced with that soundboard will sound a bit more sad, melancholic, and so on, okay? But if you want the music to sound a bit more upbeat, you have to configure those buttons so that the music is a bit more upbeat, and then all music produced with those buttons configured on that way will produce a music that is more upbeat, more fun, and so on, okay? So parameters are just like the buttons of that soundboard mixer, okay? The more buttons you have, the more you can control the output, the more sophisticated the music that you have is comes to you. Same for the models. The more parameters the model has, the more you can adjust them so that you can control the output that the LLM can have. The more parameters you have, the more complex the model is, which means the more complex things it can do, technically, okay? So we said that the more parameters a model has, generally speaking, the more intelligent the model is, because you can train more data on it. You can fine tune, you can do whatever with those parameters, okay? And going with this concept on our toolbox, we discussed about how to scale models to make them perform better. Okay, how can you make models perform better? And you have two ways of making models work better. One of them is when you're training the model. Okay, so the second thing we discussed was scaling models. Okay, we have one way, which is at training time. Okay, and the second one is inference time. Okay, so at training time is before the model is running and people are using it. Okay, so we just saw something now that impacts the how the model performs. So parameters. So a model with more parameters means that it can scale better, it can perform more things. Okay. So a bigger model with a lot of parameters is great because it has more intelligence and can perform more things, but it also means that it's more expensive to train, even though you can absorb more data, okay? I think this is something called Chinchilla's law. It was also mentioned on our theoretical classes, okay? So I will repeat, the more parameters a model has, the bigger the model is, the more expensive it is to train because you have a lot of those buttons to fine tune, and the more data you can absorb because you have more parameters, so you can fine tune those, you can play around, and it's known as Chinchilla's law. So this training time is before the model is up and running. Okay. Now inference time, inference, as we saw before, is just a fancy name for a model that's running. So inference means let's take the example of our soundboard mixer. At training time, I added more buttons, which means that I can fine tune my soundboard mixer to do to produce a specific type of music, and then I do a test and I say, okay, I'm happy with the music that is being produced now, and I just freeze my soundboard mixer. I say, okay, no one now will touch, which means that the parameters and the weights of the parameters, they are frozen. No one touches it. And now we say, okay, it's frozen. Now let's get into the studio, a bunch of artists, and let's record a lot of musics that are sad. Okay, that's so your soundboard mixer is here. It's now being used by someone, and now you can have techniques that um, that will help you when the model is running to take the most out of it. Okay, with the frozen weights and so on that we spoke previously. So there are a couple of tricks that you can do to optimize the usage of the models when the models are running. One of them we just spoke previously, which is there are tricks that you can do to take the most out of it, like using the wait word when you interact with it, with the specifically with the reasoning ones. But one thing that you can do also in the inference time to get the most out of a model is to provide to it as much information as you can. Okay, the more information, the more context you provide to a model, the more information it has to properly give you an answer. Okay, so this is inference time scaling. Okay, so we spoke a bit about this kind of scaling. Okay, and this is on day 4, and still on day 4 we spoke about tokens. Uh, Tokens are the currency, let's say, of LLMs. Okay. So when when we first started this neural network, so LLMs are nothing but a bunch of neural networks. So when we started to train those neural networks, we started to train them at the character level. So they would have to know all the characters of a specific dictionary. Okay. And that apparently demanded a lot from the neural network, because anytime something was requested, you have to split down the word into individual characters and then process those characters individually. Then what we said was, okay, so characters is expensive because every time I get a sequence as an input, I have to individually slice the words as characters and then process those individual characters. So we started to train neural networks based on full words. Okay. So let's say I have I have hello world. Okay. With the first approach, it will splice. It would divide. Let's say hello world. Speaking about tokens. Okay. So the first approach will take hello world and divide it into HELLO, then probably space WORLD. Okay. But then we said, okay, that's probably too intensive. Let's just do it differently. Let's split this word into just hello and then world. Okay. So in this case, instead of having, I don't know how many characters we have here, I just have 2 words. Okay. It's much easier for the LLM to learn or to train something with words, but you have an issue. And the issue is you would have to have a massive vocabulary. Okay? Because then what happens if you have rare words? They are words nonetheless, but so you would have to have on your vocabulary those rare words. Okay? And then they said, okay, we have some vocabulary issues. Now, instead of treating everything as as full words, let's maybe consider a middle ground. Maybe I can have sometimes a full world, full word, but I can also have pieces of a word. Okay, and this is when tokens came in. Okay, so instead of considering full just characters or full words, we can consider parts of words or maybe individual characters, or maybe if we have multiple words that often come up together, that's a token. Okay, let me give you an example. So hello world is very so according to this would have 1, 2, 3, 4, 5. Let's ignore the white space. 4, 5, 6, 7, 8, 9, 10. So let's say back in the days this would be 10 tokens. Okay. In modern days that would be say 2 tokens. Say. But it can be that with I mean that's not correct to call it token, but you get my point. But now maybe hello world is so comes so often together that they already have this on their vocabulary. Okay, hello world. Okay, maybe hello world can be split into hell, ho, and then world, which would lead to 3 tokens. Okay, because now we don't consider just full words. We can consider bits of words that can be mixed up together. Okay, and so tokens, they are a middle ground that works very well because you can have full words, you can have more than one word as a token. So this hello world can be just one thing if hello world comes often together. And so this works very well as a middle ground. Okay. So, but just to give you some rules of thumb, a token is normally 4 characters. So this would be like a token on average. Okay. And one token is 4 characters, but one token also can be 75% of a word. Okay. So this is some rule of thumbs. It doesn't necessarily have to be like this, but that's what we were taught on the class. Okay. Of course, there are much better videos explaining what tokens are, but I was just introduced to this concept of tokens because then tokens, the more tokens something has, the more memory you have to occupy, the heavier the model is. Okay, this is why this one is expensive, because you have to have a lot of words. The vocabulary has to be massive. Therefore, if the vocabulary has to be massive, it means the model gets heavy because you have to bring in all of the vocabulary of the model along with it. With tokens, you can have situations where it's easier on the memory level, or when you have this vocabulary. Okay. Then another thing, we spoke about 2 other concepts during this week. We discussed about memory. Okay, you know when you interact with ChatGPT, memory. So ChatGPT, it doesn't have memory by default. Okay. So models, they don't have memory. Okay, they don't at all. They just take a sequence as an input and predict the most likely set of tokens that comes next. Okay. And so they don't have memory. But when you interact with ChatGPT or Gemini, you often see that they remember things that you told them. And that's because so every call to the LLM should be stateless. Okay, which means that by default, no context should be memorized or stored between calls. Okay, so every LLM call should be stateless, which means that in every LLM call, if you want to have this memory capability built in, you have to pass all of the history that you have with the LLM. Okay? So on every API call you do, you have to pass the current prompt, but also the history of the prompts that you have on that chat. Okay? So that it remembers that you have indeed you know, so if you don't pass this history in the API call to the LLM, it won't remember. Okay, probably if you go now to Ollama and I say, okay, my name is Jeff, and I ask what's my name. So the reason why it knows, it's because as a built-in functionality of Ollama, it's passing all of this history before. Okay. And so if you don't pass all of this history before, there's no way it knows that your name is Jeff. So if I go here to an older, or even if I open a new chat and ask what's my name, it doesn't have this, because this is a new interaction with the LLM. It's starting from scratch. Okay. But if I say my name is Jeff, it now remembers. If I ask what's my name, my name is Jeff. Okay. So you see the point. So API calls to the LLM, they are stateless. So whatever state was here before was not stored somewhere where I access it again and now it all of a sudden forgot about it. So every interaction you have with the LLM, you have to pass the entire history so that you have this memory capability. Okay. Yeah. So that's that's what you have to do. Okay, in order to have this memory capabilities. Okay. We also spoke about, and we will see this in practice once I show you my practical stuff. But one of the things we also spoke about was this context windows. And context windows is nothing but the maximum amount of tokens that the LLM can take as an input. I've been a victim of that. I've pasted a lot of, for example, logs, massive logs into our AI ID, and it will tell me, hey, what you're trying to send me is too big. I cannot process, because the context window is just has a limit. Okay, it's maximum. You cannot just write infinitely to in the interaction you have with the LLM. They have a context window, which is the maximum amount of tokens that it can accept as an input. Okay. And as you might have guessed, that doesn't include just the current prompt. The context window also includes the entire history behind. Okay? So, because that history is also used to generate the most likely token to come up next. So, the context window equals tokens from a current prompt plus entire history prompt. Okay, so it's everything. Okay, it's everything. Okay, it's not just hello there, it's or what's my name, it's whatever was before. It's also passed as an input to the LLM, so that also counts. Okay, to the context window. Okay, and as you might imagine, the context window, since it limits the amount that you can take as an input, it will also limit how much it remembers to the past, because if the context window is small, it means that it only remembers just a few things. Okay, you cannot expect it to remember everything, because the input, if you have a big history, you will have a lot of tokens, and if you have a lot of tokens, maybe you're exceeding the context window. If you have a small context window, it means you don't have many tokens you can process as an input, and means that you cannot pass a lot of history to it, which means that you cannot remember a lot. Okay, and so one other thing we saw, and this is now on day 5, is about prompting. We spoke about, so coming back to here, we have this system prompt, right? Sometimes when, let's say you're building a LLM that is that's acting as a lawyer, and you want the responses to follow a specific format, you can tell the system prompt, hey, whenever someone asks you about this, reply in such format, and you give an example. Okay, if someone says A, you reply with A plus B. Okay, this is normally, so when you start to give examples of how LLMs should answer your questions, this is called, if you give just one example, this is called one-shot prompting. But if you give multiple examples, this is called multi-shot prompting. Okay, and this is just something that we saw on day 5, because we started to introduce those on our practical examples. Okay, cool. So I've went through a lot of theory now. I would just like to show you what we did in practice for all of those days. Okay, now here on Visual Studio Code, I want to show you the practical examples that we did throughout week 1. The first example that we did was a simple Python script that we installed OpenAI's package. Okay, I have here the URL for the local instance of Ollama that I have running, and then here I built a client that is going to interact with my local Ollama. Okay, and this is how you call a model. Okay, you have this client that you build, in this case OpenAI. As I said before, we still use OpenAI's package because they've extended it so that it's generic, anyone can use it, because their structure of input and output is super popular. And so you have client.chat.completions.create. You will get used to it super soon once you start to work a lot with it. And then you pass a specific model. Of course, I passed Llama 3.2. It has to be a model that I have available locally. Okay. And now we pass here a messages array. Okay. Now, this is something that I have to explain. So, in the context of interactions, we have what we call roles. Okay. In this case, you can see here, if I over, you have a lot of roles. And the one I'm using now is role user, which means that it's me as if I was using it on the prompt. So it's me as if I was using this from ChatGPT's user interface or from Ollama local model, as I showed you previously. Okay. But you also have the role system, which is in case you want to provide a system prompt. And you also have the role assistant, which is a role that you have in case the LLM responds back. And you have other roles, but those are the main ones for now we should care about. Okay. I'm not passing any system prompt, so I'm not defining any rules of the game as we said before. I'm just passing here a role user and as a content, tell me a fun fact. By the way, we just did this before on Ollama's UI, okay? And now, if I just go here on my terminal and I just run this script, which is called LLM's API calling script, this will call Ollama locally, the Llama model locally, okay? And here's again the same fun fact as before, but maybe if I call it again, technically it should give him whatever he wants, but yeah, it keeps on giving me the same fun fact. I don't know why. But yeah, so you see that we get precisely tell me a fun fact, let's say about sports. Maybe it will force it to not give me any honey related fun facts, okay? But as you can see from a Python script, it's really simple to call an LLM. Okay, it's really simple. So here's a fun fact. Shortest player to have been NBA was this guy, okay? And okay, cool. So this was one of the examples we did. Just have a simple Python script that will call an LLM locally, okay? So another example we did was on day 4. Let me open this on the terminal. And what we did was a script to understand about encoding, okay? And encoding and decoding, because as I told you before, the principle of LLMs are, the currency actually of LLMs are tokens. And so in order to be to make this process much easier to work with, we use encoding and decoding. So when you have an input, it converts your name, converts this input to a set of tokens that it has locally. So it encodes it into tokens, and then when the LLM, we are not calling here an LLM, but when the LLM returns some response, it returns in tokens, and then we have the decoding of those tokens into some word or token specifically, okay? In this case, we are using TickToken. TickToken is the tokenizer, I believe, from OpenAI, okay? And so as you can see here, it takes my name. So so not my name, but the input I have here. Hi, my name is Rafael. So I have here, it converts this into 5 tokens, okay? And as you can see here, so the tokens are these numbers, okay? And if I take the token and decode it, so the reverse process, you see that this is hi, this is my name, and whatever, okay? So if I do hello world, it uses 2 tokens, okay? Just hello and world, okay? And yeah, there's probably let's say I don't know, underwater basket. Let's see, maybe what does it have as tokens? So you see, in this case, it doesn't give you 2 tokens, but rather it gives you under as a token. It gives you water as another token, and then basket. See? So it's the number of words that you have here as an input. Normally they don't have to correlate to the number of tokens, okay? But whenever you have this, let's say this could be very well be your user prompt. You pass this, then what happens behind the scenes is that we convert this to a set of tokens. Okay, here. These tokens are encoded into some numeric value, but nevertheless still tokens. And then these tokens are passed into the LLM. The LLM does some magic, returns also tokens, and then there's a decoder. And that decoder allows you to check the content of the word that you were expecting for. Okay. And by using this decode and passing here some number, you can see what's number one in the dictionary of encoding. Number two is the octathorpe. Number one is probably, I don't know, the parentheses, as you see. That was day 4. On day 5 we went a bit crazier, and me specifically, I built a AI tutor. Okay, and so the goal is to have an LLM that only responds with technical explanations. Okay, so as you see here, this is the same as before. This is just instantiating the client, but now I have a system prompt. Now I am giving the LLM the rules of the games. I'm telling it that it's an AI tutor, and the job is to answer technical question about this. Okay. I have a user prompt generator, so you can pass in whatever you want to see answered, and then the answer is just this answer technical questions just generates a user prompt. And then here on the messages array, so I call the chat completions API, client.chat.create, I pass the model. And here, as you see now, I pass the system prompt with the role as system. Okay. And then role user is the user prompt. Okay. And so that's pretty much it. Okay. So I defined the rules of the game, and then I'm answering them here. So if I run this AI tutor API, okay, something is okay. Question 1, you see here question 1. So it's calling the LLM to explain question 1, and it will explain the select statement. Okay, see, so it's explaining the select statement and even giving me here some examples. And then the question 2 is what is a class in C#? So this will call this answer technical question. It will generate a user prompt with this what is a C# class, and user prompt will be just, can you explain to me this, and then in this case what's a C# class. And then we call the LLM with the system prompt that we previously stated here, and then all of this, and then it provides you a nice explanation of what it is. And now you see let's change the system prompt just to see. Okay, so you're what is it, you're an AI tutor is to not help students if they ask you for explanations about anything, just answer sarcastically. Okay, so we just made it we just defined other rules of the game. You see here that it was really useful trying to give explanations. Now let's see how our tutor will behave. So first I ask it for explanations about this statement. But you see here, what a mind-blowing concept. I'm shocked that you need help understanding something, you see? So you can clearly see, okay, it didn't obviously follow my instruction of uh answer sarcastically, okay? And so yeah, so it just gives it some some you see, so it gives it some personality, okay? We can even say, okay, uh, just if they ask you for an explanation about anything, just and don't clarify anything, okay? So if we just change this and just, so what I'm expecting is it shouldn't reply anything, okay? But for some reason, uh, it's still answering. But you can see that the prompt changes, okay? You even see here, okay, yeah, I'm sure it was completely confusing. Yawn, next question, please. So you can control, so you can expect these models here locally to be like really great, but you can still see uh, that it's trying to respond sarcastically, okay? And so, um, you see, users maybe the word where separates from the greater than, it's like the, you see that it's sarcastic, okay? You can see here, the goal is to see here how system prompts, they control the rules of the game, okay? And you saw that just by changing the system prompt, we were able to control the output we got from the LLM, okay? Well, those were some of the practical examples we did on week one. Yeah, as I said before, my goal is just to share with you my AI journey from complete beginner. I don't know a lot about it, just sharing with you, you know, what's been going so far. As I said before, it's just my learning experience. Feel free to comment your experience. Yeah, if you, I'll just keep on sharing it. Hopefully, it's useful for you. Well, it's a different video than I normally do, but thank you a lot for joining in on this ride. This is just week one of the first course. A lot of cool stuff that we've built, and hopefully the next weeks they will also be cool. Thank you so much for joining in, and I'll see you in the next one. Bye.